Current live session for the course system design through Verilog. Priyanka. So Priyanka, you have any questions? Yeah, any questions?
Sir,
Yeah.
how to implement the borrow expression of a full subtractor using means if we have given e means inputs.
Sorry, can I repeat the question?
Sir, how to means evaluate the borrow expression of full subtractor if we have to write the conditions using true and false.
Full subtractor is actually if you take 3 bits 0, 0, 0 is anyhow no borrow is required, and difference is 0. 0 minus 0 minus 0. If you assume that the inputs are x, y, z and outputs are borrow and difference. Okay, so this will perform x minus y minus z. If you take all zeros, both borrow and difference will be 0. And if you take the second case 0, 0, 1. So that means you have to perform 0 minus 0 minus 1. For the first 2-bit subtraction 0 minus 0, no borrow is required, and the difference is 0. So 0 minus 1 again. So to perform that 0 minus 1, we require a borrow. So borrow is 1. If you take a borrow, that becomes 2 actually. So in case of a decimal, if you take a borrow, it will 10 will be added to that number. For example, if you want to subtract 12 minus 9. Okay, so at one's position, if you want to subtract 9 from the 2, you have to take a borrow. If you take borrow, that 2 becomes 12. 12 minus 9 is 3. So in a similar manner in binary also. So if you take a borrow, if you want to perform 0 minus 1, so 1 is greater than 0, so we need a borrow. So if we take a borrow, 2 will be added to 0. So 0 becomes 2, binary 2. So in that 2, 1 you are subtracting. So 1 is the difference. So we require borrow as well as difference is also 1, borrow is also 1 in case of 0 minus 0 minus 1. We can perform the remaining the 6 columns also in a similar manner.
If we given an input such as y, a, b, c, d, f, so how to means write the conditions using the borrow expressions? So what is given? Y? If we have given inputs y, a, b, c, d, f, suppose 6 inputs, so how to write?
Not that many inputs will not be there enough for a full subtractor. Only 3 inputs, 2 outputs.
Actually, the assignment 5 question, I have doubt.
So what is that question? Can you read?
Is given a Verilog code and given the conditions E and A, B, C using the equation.
Actually, that actually I have implemented by using the multiplexer. Okay.
Yes, sir.
So if you want to implement any Boolean function using the multiplexer, so I will explain on the screen. So if x, y, z are if x, y, and z are the inputs, and borrow and difference is the output. So 0, 0, 0 is difference is 0, borrow is 0. 0, 0, 1, both will be 1. 0, 1, 0 also, both will be 1. 0, 1, 1. So 0 minus 1 requires borrow. So this is 0, difference is 0. 1, 0, 0. Difference is 1, borrow is 0. 1, 0, 1. 1 minus 0, difference is 0. Borrow is also 0. 1 1 0 is also same case. 1 1 1 is we require a borrow because 1 minus 1 becomes 0. 0 minus 1 to perform 0 minus 1 we require a borrow and difference is also 1. So if you write the Boolean expressions are in terms of the min terms. So this B will be having min terms 1, 2, 3, 4. So this min term is 1. This is 0 in decimal 1, 2, 3, 4, 5, 6, 7. So the min terms are 1, 2, 3 plus 1, 2, 3, comma 7. And difference is sigma m 0, 1, sorry, 1, 2, 1, 2, 4, 7. So if you want to implement a borrow using a multiplexer, we can use, we have 3 variables here. B is a function of 3 variables x, y, z. So we require 2 control signals. So you see the multiplexer, we have 2 control signals, 4 by 1 multiplexer. So out of these 3, we have to give one as a control signal. We can give either x or y as control signal, selection signal. If I give as x, then this will be having 4 inputs I0, I1, I2, I3. So these inputs you have to choose from the other 2, y, z, 0 and 1. So the output, if I want to implement, say borrow. So to implement this, there is a procedure to implement any Boolean function using a multiplexer. So we have to take this I0, we have to find out I0, I1, I2, I3. I0, if you want to find out I1, I2, I3. This is, we have to require 8 by 1 multiplexer, sorry, 2 control signals are required. N-1 control signals. If you want to send controls, N-1 control signals, this is S1, S0. Remaining X we have to use for finding. This is X and this is Y. So if you want to implement this one, I0, I1, I2, I3, then X bar, X. If you see in the previous, this one. So here X is 0 in the first 4 min terms. So this is X bar. X is 1 in the remaining 4 min terms. This is X. So the min terms along X is 0, 1, 2, 3. The min terms along X is 4, 5, 6, 7. So in this, what are the min terms that are present in B 1, 2, 3, 7? 1, 2, 3, 7. Out of this, because X is 0, this is X bar, X bar, X. X is in 0, 1, 2, 3. First half X is 0, the remaining half X is 1. So what are the min terms that are present in B is 1, 2, 3, 7. You have to round this 1, 2, 3, 7. Then the value of I0, I1, I2, I3 will be, if both are not encircled, then the value of this one is 0. So I0 becomes 0. I1 is upper one is circled. So upper one is correspond to X bar. So this is X bar. Here also upper one is circled, X bar. Here both are circled means the value is 1. So in the borrow implementation, if I take this borrow implementation circuit, 2 control signals, S1, S0, I am giving as YZ as the inputs because X I am using here. So I0, I1, I2, I3. This output I want B. So what should be this I0 is X. 0, sorry, this is 0. I0 is 0. I1 is X bar. I2 is also same X bar. I3 is 1. So this will implement borrow. In a similar manner, you can implement the difference also. Cannot implement a Boolean function with a function of 3 variables X, Y, Z. So the last n-1 variables you have to give as the control signals or selection signals. So if the relation between the inputs and control signals is, if you have n control signals, 2 raised to the power of n inputs. So this is how you can implement the borrow. Similar manner, you can implement the difference also. Is it clear?
Yes, sir.
Is it clear now?
Yes, sir. But sir, using the conditions like in multiplexer, we write A is
Actually,
true.
I might have asked it in a different manner. So I have given the inputs and all, and you will be asked to find out what are the minterms. So you can ask the question in many ways, but the procedure is this one.
Okay.
If you know this procedure, you can answer that question. So any more questions?
Sir, what is bit files and elif files in Verilog?
Bit files and
Elif files.
what is second one? I am not able to listen properly. Bit file and the other file is what?
Elif file. ELIF.
So this is with respect to this Verilog course.
Actually, the project I have assigned now, Verilog code using means you have to implement using elif file and bit files. Can we implement in Xilinx?
Yeah, I can implement the Xilinx.
Sir, what is the meaning of buff if one y, x and c?
Buff, you have one control signal. In buffer, will be having one input and output on control signal, right? So if the control signal is 1, then the output will equal to input. If control signal is 0, then output will enter into the high impedance state. High impedance state means, as the name implies, impedance is high means it's almost acts as an open circuit. It does not draw any current from the circuit where it is connected. On the other hand, we have buff if 0 is also there. So that is reverse operation. If control signal is 0, output is equal to input. If control signal is 1, then the output will be input. If this control signal is 0, then it will be high impedance state. Buffer simply transfers the input to the output. In addition to this transfer, there is one more state called high impedance state. So for one value of this control signal, the output will be high impedance state. If you don't want to load the remaining part of the circuitry, normally we'll keep this tri-state buffer into high impedance state. Is it clear?
Yes, sir. So can we write the FSM code in synchronous circuits or asynchronous or in both?
Asynchronous is actually there is no FSM and all. There will be just by observation only can design that asynchronous circuit. Mainly this FSM will be written for the synchronous circuits. Asynchronous normally by observation you have to, because the clock is different. In synchronous clock is similar, clock is same. So we have this FSM and all state diagrams.
Sir, what is the meaning of negative reset?
Negative reset is actually if it is of negative logic, reset is 0 means reset operation means regardless of the inputs, all the flip flops will be cleared. Reset, if reset is equal to 1, all the flip flops will be cleared regardless of the input. If reset is equal to signal, that can be called as reset bar. Okay, so if reset bar is 0 means reset is 1, so reset operation. If it is simply reset, positive active means positive signal, positive logic signal, then reset is equal to 1 means reset operation, reset is 0 means normal operation. There are two types of the resets. One is reset, which is called active high signal. One is reset bar, which is active low signal. So if it is a reset bar, to reset the signal, we have to make reset bar is equal to 0. If it is active high signal, signal is reset, so you have to make 1 to reset the circuit.
Sir, in universal shift, sir, in universal shift register, what is the meaning of parallel loads if we apply I0 and I1?
Actually, what happens is all the registers, all the flip flops will be loaded with this data simultaneously. If I give one clock signal, then all the I0, I1, I2, I3, whatever the data that you have present, whatever the data that is presented I0, I1, I2, I3, that will be loaded into that particular flip flop. Because in case of D flip flop, so output Q is equal to D. If I apply the clock signal, so the input will be transferred to the output. So in that way, we can parallelly feed the data using that I0, I1, I2, I3. That is parallel in operation. Is it clear?
Yes, sir.
Yeah, please.
So which style is better, like if else condition or a change statement?
Your voice is not clear.
Sir, I have a question in chat.
Okay, I'll see. You write it. It's not there. You write it. Case will be more efficient because in case of if else, we require a multiplexer type of thing. Whereas in case of case statement, directly we have registers, directly we load this. If some condition has to be satisfied, means you have to use this multiplexer type of things. Efficient in terms of what? There are many things in efficiency. So one is actually in case of the hardware perspective. So if want the good, I mean logic is if else only. So if you want to have a good practice, it is if then else only. Because this, if we want to write the case, no need to understand the operation also. Actually, you can write the values for these inputs. This will be output for this input. This will be output. So no need to understand the circuit operation. Okay. But in case of hardware, if you see the hardware efficiency, so in if then else we require a multiplexer, whereas in case statements we require just simply loading these values onto the registers. There is a case if it is 0, 0. So then some data will be loaded into register 0, 1, some other data. So like that. So this data will be stored. But if we term in terms of this programming skills and programming, this one it's if else is also better.
Sir, if we given a test bench of a code, so how
Yes.
to means evaluate the time at t equal to means 50 seconds without plotting the graph of
That there is a hash symbol is there, hash symbol. After that you have to give the time. So if you want to observe the waveform at any time, you give hash symbol and then that time value. So if you want it 5 seconds, then hash symbol followed by 5, so that the output will waveform. Waveform changes at 5 time units. So any time can be given hash. There is a hash symbol is there. After that you can give any time. So you can observe the variations at that particular time.
Sir, values how to determine means if we have a test bench.
In test bench you have to give the values. Test bench depends upon this programmer. So programmer can choose any time values. You have to choose a clock basically. With respect to clock only, you have to plot the remaining inputs and outputs. So the clock you can take something like a clock for every repeat clock for every 10 time units, say. So I'm not mentioning milliseconds, microseconds, that you can mention in the starting of this one time scale. 100 by some 1000 picosecond means it will go up to 100 nanosecond with the increment of 1000 picoseconds. Okay, that notation is there. So here, whatever the time scale that you are going to define, hash followed by that time. So during that time only the output waveforms will changes with respect to clock. If clock period is say some 20 nanoseconds, for every 10 nanoseconds it will changes. It depends upon if it is a D flip-flop, it will change at the positive or negative edge. It depends upon the Verilog code that you have written. So initial thing is that you have to give the clock. So clock can be given by using that tilted form, say some 10 nanoseconds, the clock will changes means. So for 10 seconds or nanoseconds, whatever it may be, 10 nanoseconds, it will be on. Again for the 10 nanoseconds off, 10 nanoseconds on, 10 nanoseconds off means the time period is 20 nanoseconds. So for every 20 nanoseconds, the clock will repeats. So in between, if you want to check the outputs, you can give that value. If the finish time is, say, for example, at some 200 nanoseconds. So 0 to 200 nanoseconds at any time, if you want to check, you give just a hash symbol followed by that time. Is it clear?
Yes, sir, what is the difference between Bob-Woolley and Brown multiplier?
Bavuli is signed multiplier and Braun multiplier is unsigned multiplier. That is the only difference. If you want to deal with signs also, then you have to go for Bavuli. Unsigned means Braun multiplier. Clear?
Sir, in digital processing applications, we use signed or unsigned.
Signed in almost all applications we need signed because wherever the data is positive as well as negative. Then in communication, in many applications, data can be negative also. Signal can be negative also. Sinusoidal signal, if you take sinusoidal signal, it will have positive values, negative values. Okay. So you take most of the real world signals, they will take both positive values as well as negative values. So normally we have to implement the signed multipliers only. So only 3 more minutes is there. If you have any questions, you quickly ask. Otherwise, you can ask in the discussion forum also.
Sir, if we implement positive logic using AND gates,
Yes.
so if any variable is assigned as a value of 1, so what happens?
Yeah. Positive logic means logic 1 means is for plus 5 volts. Logic 0 means 0 volts ground. If it is negative logic, plus 1 means logic 1 means it is 0 volts. Logic 0 means 5 volts. Physically, ones and zeros will be given in terms of the voltages. Okay. If you take ideally 0 volts and 5 volts, that varies from the logic family to logic family. So in positive logic, logic 0 means 0 volts, which is ground. Logic 1 means plus 5 volts. In negative logic, reverse. Logic 1 is ground, logic 0 is plus 5 volts. Clear?
Sir, if we assign 0, then it is reverse in the positive logic.
Yeah, logic 0, 0 means in logic 0, 0 means which is 5 plus 5 volts. Physically, it was logic 1. In terms of voltage level, it is plus 5 volts. But most of these ICs uses negative logic. The reason is NAND and NOR gates are universal gates. So because of that, normally negative logic will be used in many of the ICs. Okay, it's already 4. I think there is one more live session is there here for the other course. And I have also some meeting at 5 o'clock, 4 o'clock. So if you have any other questions, you can ask in the discussion forum. Okay. Thank you for your participation.
Sir, one more question.
Please quickly ask because I have meeting also here. Also there is one more.
Sir, if we write not operations, suppose A we write not after not or before means we have to write.
First you have to write not, then A. First you have to write the symbol, then A. That is not operation.
Sir, in assignment, it is right after not.
Except for the not, remaining all will be operator will be written after the variable. In only not operation, the operator will be before the variable.
Okay, sir.
Okay, thank you. Thank you for your participation. Good luck for the final exam.